Hello, this is Dr. Liu, and today we're going to discuss the Pythagorean theorem. And before we discuss the theorem, I want to throw a question at the audience. So you're taking an online class for sure, and you're on the computer all the time, right? So you probably have a laptop. Like myself, I have a laptop. So let's get this laptop here. All right, where's my mouse cursor? All right. So I drew a laptop. Okay, so you have a laptop, but the laptop is pretty small. So you're staring at this tiny screen all day long, and you're thinking maybe you should get a big screen so that you can watch videos a bit more easily. So let's think about this. You're thinking about making a purchase. So over here, let's get this big screen right here. Okay, that looks pretty big, right? But then you're thinking, okay, is it too big for you? You have a pretty small table, and you don't want to run out of space, right? So let's get yourself a table here. Copy paste. So okay, we've got a table. All right, wow, look at that. This is just barely fitting. Let me move this. Let me go ahead and move it, and just move them a little closer. I think I'm skipping some of the legs. That's okay. I'll draw some more legs later. All right, so let's do a little cleanup. All right, so this is your table, and here's the front leg. All right, so you're thinking, is this screen gonna be too big or not? Let's connect them together so you could be watching the same thing on a much bigger screen. Right. This could be me talking, and well, you probably still want a cup of coffee. So you want some space, right? You need a little bit of space, and let's fill it up. It's hot. Okay, so here's a question: if you want to buy a TV or a large screen, and they don't really always tell you how wide this dimension is, how much space it's going to take on your desktop, and how tall this is. On the other hand, they usually tell you some other things, such as here the diagonal, right? Diagonal. Let's call this a D. So for example, let's buy a 24-inch. Yeah, 24-inch big screen. So we're told that the screen has 24 inches diagonal, but that doesn't tell us how wide it is. We're also told aspect ratio, such as 16 versus 9, or I like to write it like 16/9. So this is actually a mathematical expression. You can calculate it. It's approximately 1.78. All right, so you were told these two things, and you're trying to decide whether it's going to be too wide for your tiny little table or not. You still want to maneuver your coffee cup, right? You want to bump into it. So how do we do this calculation? Well, that would require us to know Pythagorean theorem and a little bit of solving problems. So let's theorize. This is no longer our big screen TV. It's just going to be this rectangle, and this is that diagonal, right? That D right there, and this X dimension is horizontal, Y is vertical, and I may as well just call this a Z. All right, and let's assume that you bought a good quality monitor, so the corners are actually pretty straight. They're not kinked. So okay, and what we know is Z is equal to 24 units, 24 inches. And we don't know either X or Y, but we know that X, oops, that doesn't look very good. So we know X over y aspect ratio is 16 over 9, right? So according to Pythagorean theorem, what this tells us is in the right angle triangle, the hypotenuse and these other two sides, they're related in this relationship. So z squared equals x squared plus y squared. And that's the theorem. So if we think about this, we're told what is z, right? The z is given to us, and we were also given x over y. So we can list that together. We can say that this z equals 24, so I know that 24 squared equals x squared plus y squared. Okay, so that's an equation. It has two unknowns, x and y. You can't really solve it because there are two unknowns in one equation. You got to have the same amount of unknowns and equations to solve them all, if they're solvable at all. So that's not enough, but now we also have this x over y. That's another relationship, or we can call that another equation, right? So 16 over 9. So now we have a system of two mathematical equations. I like to number them so I can refer to them later when I'm solving them. Okay, so we have two unknowns, x and y, right? So two unknowns, x and y, and we have two equations, so this should be solvable. And let's start solving them. So from equation 2, what we can get is x over y. Let's just write this vertically. I know not everyone likes the slanted or horizontal fraction. So we know that x and y are related this way. So if I multiply both sides with a y, and then the left side will be just x. The right side has a y multiplied to it, right? So that's that. That's still equation 2. I didn't do anything to turn it into another equation. All I did was I did something on the left side and the same thing on the right side. So this is the same equation. But now this looks like x hasn't been solved in terms of y. So I can take this and substitute the x here with this expression, so the x will be gone from this equation and only leaving y. So then I'll have an equation with only one unknown. I should be able to solve it. So now we substitute x into equation 1. So x into equation 1, or equation 2 into equation 1. So let's go ahead and do it. So 24 squared equals 16 over 9 y squared plus y squared. And that's also equal to 256, that's 16 squared, 81 is 9 squared, y squared, plus another y squared. And that was the original y squared right here. And this whole thing was the x squared. And we can combine the y squared, it's 256 over 81 plus 1 over y squared. So at this point, you are probably inclined to pull out your calculator and start calculating this value. I don't really worry about that because I think this is irrelevant. This is just a number. If I can drag it around, I can drag it around. I don't have to turn it into a numerical value. This way I can show where these numbers came from. So now we have an equation. The left side is a numerical value. The right side has the unknown, another numerical value we can divide out. So if this whole equation is multiplied by this 1 over this factor, 256 over 81 plus 1, this kind of ridiculous factor. So I want to say this is equation 1, still called equation 1. So this one multiplied by this factor on the left side and also on the right side. This factor multiplied on the right side will divide this out. On the left side, it will just stay in the denominator, and that becomes the numerator. So we have 24 squared divided by this whole thing, 256 over 81 plus 1 equals y squared. So if I take a square root on both sides of the equation, I should get a y, right? So I can say that, we'll take a square root of equation 1. So what do we get? And also I want to switch the left hand side and right hand side so I can get y on the left hand side. And this 24 gets square rooted. 24 squared gets square rooted. And the rest gets under a square root. Okay, so now we can use a calculator. Okay, so what I do is I use this calculator here. This is Python, and it's perfectly good as a calculator. All I have to do is to type the expression I just wrote for y. So I want to say that y is equal to 24 over this whole square root, which I'll put inside of a parenthesis, 256 over 81 plus 1, and that needs to be taken square root, which means raised to the power of 0.5. This double multiplication means raising to the power of what? So there you go. And if I ask what is y, this is giving us y. So the height of this monitor is about 12 inches. May not really concern you too much because you still have space vertically, right? So what concerns you is x. Let's just, for the moment, let's dismiss that. We'll just write this 11.8. So 11.8, and this is actually in inches. All right, so we're almost done with our final answer, whether it's going to fit your table. So now that we have y, remember how we did it was we took equation 2, we massaged it into a solution looking expression, which we plugged into equation 1. And that caused equation 1 to drop one unknown, and it gets reduced into just a single unknown, which we later solved. So if we go back to this expression, we should be able to get what this x is. Actually being better, this is the better equation. If I plug y right here, I can get x, right? So this is still equation 2, right? That's from equation 2. So I'll just say that equation 2, I have x equals 16 over 9 times this number 11.8. So what exactly is our x? Alright, so I still have the y here, so I'll just say x equals 16 over 9 times y. Okay, so let's find out x. Wow, that was almost 21 inches. I thought I was buying a 24-inch diagonal, but yeah, it's a wide aspect ratio monitor. These are the monitors you can buy these days. You can even buy more ridiculously wide monitors, but I bet most people don't have a wide enough table to fit them. On top, maybe you'll have to buy a nice desk to get that monitor to stand on a nice desk. But this is our answer, 20.9. Okay, so 20.9 inches. So that's how wide this monitor is. And do you have space? Well, that really depends on your situation. I feel like my table is not very big, so I may not want to go for the next size up. That means maybe the 27-inch will be out of the question. Unless I don't want to drink any coffee, I just want to cram everything onto my desk. All right, so I hope this was helpful with the Pythagorean theorems review, and also the solving a system of two equations, and some practical application of how large these monitors are. Well, I didn't really include the bezel size, although those bezel sizes are actually getting smaller and smaller into even invisible, quote-unquote, invisible sizes. So that was it. Thank you.